For a one-step equation, I understand it. Most of you guys can eyeball it. I'm making this problem seem a lot more complicated than it should have, but trust me on this. Learn the foundation in this lesson, learn how to balance a basic equation like this one, and then that will help you for problems that you can no longer eyeball. In a few sections, you're going to be learning multi-step equations. You cannot eyeball what the answer is. So once again, practice now knowing how to use the balancing method with the easier equations. So for example 1, I'm going to rewrite it over here. It's r plus 12 equals 25. So we draw a line through the equal sign. The reason why is, think of that equal sign like a seesaw. So here's my seesaw, and right here, this right here represents my equal sign. The left side is the same weight as the right side. And you're going to use that concept to understand what I'm doing here. So now go back to where the blue equation is. My job is to get the r by itself. I want the r to be by itself. And right now, on the left side of where that line is, there's a plus 12. I need to get rid of that. My objective is to isolate the variable, and I have to get rid of all the numbers on the same side as the variable. So in order to get rid of a plus 12, you got to think of inverse, right? Opposite. So to get rid of a positive 12, I need to subtract 12 because plus 12 and minus 12 are opposites. So if I do minus 12 here, plus 12 minus 12, that equals 0. And in math, right, 0 means nothing. So it's gone. It's eliminated. But now think of my seesaw example here, right? If I took 12 pounds away, right, so imagine the seesaw here, and I took away 12 pounds. Well, wouldn't the seesaw look like this then? Wouldn't the right side weigh more than the left side? So in order to have the seesaw go back to being balanced, I have to also subtract 12 to the other side. The golden rule in math is what you do to one side, you must do to the other side. You want to always keep the equation balanced. You always want the left side to weigh the same as the right side. So then 25 minus 12 is 13. I bring down the equal sign, and I bring down my letter r. And r equals 13. I want to make it clear once again, a lot of you could have just looked at r, been like, oh, 13 plus 12 is 25. Done. But down the road, it's going to get more challenging, so you have to use the balancing method. This is what I'm talking about. I need to see this in your work moving forward. So example 2, I'm going to go a little bit faster now. I just had to go over the principles, the concepts, and why we do something. So example 2, you see the work already, but I'm just going to add a little bit to it. It's 32 plus x equals 14. Once again, one thing that this example is not doing is not drawing a line through the equal sign. Always draw a line through the equal sign. From there, the x is on the left side again. So I want to get rid of the 32. I want the 32 to disappear because I want the x by itself. So in order to get rid of a positive 32, I'm going to subtract 32. 32 minus 32 is 0. It's gone. But think of that seesaw again, right? If I get rid of 32 pounds on the one side, I have to get rid of the 32 pounds on the other side. And I have to do 14 minus 32. Because I'm doing this by paper, technically, I want to make sure that I understand that when I do 14 minus 32, I'm going below 0. So my answer is going to be a negative. And then, of course, when I actually do the work, though, I have to flip it. The 32 has to be on top, and the 14 has to be on the bottom. Because we have to borrow, we always have to put the bigger number on top when we subtract. So then 2 minus 4 you can't do. Cross out the 3. Make it a 2. 12. 12 minus 4 is 8. And 2 minus 1 is 1. So my answer is x equals negative 18. Last example, and I'll do it over here. Negative 15 plus x equals 27. Once again, you're going to draw a line through the equal sign. And then you have to get rid of whatever number's on the same side as the variable. So there's the left side and there's the right side. The x is on the left side, so I want to get rid of that negative 15. Once again, you're thinking inverse. You're thinking opposite. Well, what's the opposite of a negative 15? Well, positive 15, plus 15. If that doesn't make sense to you, remember, the goal is to make it so that it equals 0, so that it disappears. You don't want to make it equal 1. You don't want to make it equal 2, because then you got to write it down. If you make it equal 0, it disappears. And if you remember, negative 15 plus 15 is 0, so it's gone. What I do to one side, I do to the other side. And I just simply add. 7 plus 5 is 12. Carry the 1, 4. X equals 42. So now move on to the next lesson. Okay, so now this is the next lesson. Once again, I'm going to show you more work on the side here. Just follow along. A minus 14 equals 31. Draw a line through your equal sign. You got the left side and you got the right side. Now on the left side is where the variable is. So you want to get rid of all the numbers on the left side. So you see where it says minus 14? Just like in chapter 3. You treat minus signs like negatives. So that's a negative 14. How do I get rid of a negative 14? I add 14. Right? I don't subtract it. It's going to make it worse. Negative 14 plus 14 is 0. It cancels out. So then I can add 14 here, and 1 plus 4 is 5, and 3 plus 1 is 4. I'll bring down the a, and of course my equal sign, and a equals 45. One thing I didn't mention before, I'm going to mention now is, once you get your answer, you can always plug it in. So where the a is here, you can always do this to check. Plug in 45 for a, and then 45 minus 14 is in fact 31. So I know for a fact my answer is right. So you can always check ahead of time. So example 2 is a little tricky. Example 2, even though it's under the one-step equation topic, it's technically 2 steps. It takes you 2 steps in order to get the answer. So this one, I'll go a little bit slower. This is probably the hardest one-step equation technically because it's 2 steps. So it's 32 minus x equals 14. As before, you draw a line through the equal sign. But do you see how the x is a negative x? That's different than all the other problems that we did. Usually the answer might be a negative, but the a itself is a positive. Right here, a was a positive, a was a positive. Over here, r was a positive, x was a positive, and x was a positive. I want to be clear. I'm not saying the answer was a positive. I'm just saying the letter itself was a positive. But in this example here, x is a negative because there's a minus sign in front of it. Whenever you have that, you should always put an invisible 1 in front of the x. So I'll do it with a different color. And now it says 32 minus 1x equals 14. And now you can solve like you normally would. The x is on the left side, and of course you have the right side here. And you get rid of that 32 first, like before. How do you get rid of a positive 32? Once again, right, I'm looking forward. And that is a positive 32. My goal is to make it 0. So I'm going to subtract 32 so that it equals 0. I cross it out. What I do to one side, I do to the other side. This time, I'm just going to go right into it. 14 minus 32 is negative 18, right? 14 minus 32 is going to be below 0, so it's negative. And then you have to flip it once again in order to actually subtract. So it's going to be negative 18, but this is the part that gets kind of funky. You need to bring this guy down. So it's negative 1x equals negative 18. And then from here, in order to get the x by itself, right, I want the x by itself here, what is the operation between the negative 1 and the x? Is multiplication. So the inverse is division. So you got to divide by negative 1 to get rid of it, so that the x is all by itself. But what you do to one side, you do to the other side. I can now bring down my positive x, and then my answer here will be my final step. And negative 18 divided by negative 1 is positive 18. Once again, this one is the hardest one-step example. Next example, draw a line through the equal sign. You have your left side, you have your right side. Once again, the variable is on the left side. The variable means the letter. And the operation between the t and the 5 is multiplication, right? If you don't see it, it always implies multiplication. So if you don't see it, you can put a little dot there to make you understand or see it better. That's really 5 times t. So in order to get rid of the times 5, we're going to divide by 5. 5 divided by 5 is gone. What I do to one side, I do to the other side. I'll bring down my t, I'll bring down my equal sign, and 45 divided by 5 is simply 9, right? Example 2 here is negative 7m equals 56. Draw a line through the equal sign. I see this all the time. A lot of kids are like, oh, plus 7m, or plus 7, plus 7. Wrong. See, the problem that you're thinking of something like this, where it's like negative 7 plus m equals 56. There you would do plus 7 plus 7, because that's separating the 7 and the m. However, if you look in the red problem, there is nothing separating the negative 7 and the m. So the operation between the negative 7 and the m is multiplication again. So put a little dot there if you have to. And the opposite of multiplication is dividing. So you're going to divide by -7. Please make sure you divide by the negative as well, because if you divide just by 7, right? Let me erase the negative here. If you divide by 7, look, the 7's cancel out. Awesome. But you have an m and a negative. You don't want a negative variable. So you want to make sure to divide by -7, so then the negative also cancels out. And the m is all by itself, which is the objective. Bring down the equal sign, and of course what you do to one side, you do to the other side. So you're going to divide this side by -7. And 56 divided by -7 is -8. Once again, don't forget, you can always plug in your answer and see if you're right. -7 times -8 is positive 56. So it's y over -8 equals 3. So here, right, line through the equal sign, you have the left side, you have the right side. The variable's on the left side, so you want to get rid of that -8. But what is the operation between the variable and the -8? This little bar here, a lot of you say it's a fraction, which it is, but that means division, right? Please understand that. A fraction bar means dividing. So the opposite of dividing is multiplying. So you're going to be multiplying by -8. Now a lot of kids don't understand this. When you multiply by -8, the -8's cancel each other out. Just give you a side example. This is something you do in your compactors all the time. Imagine if I had -8 over 5 times, I don't know, 1 over -8. Remember when you have a -8 on top and you have a -8 on the bottom? Remember they cancel out? It's the same logic here, right? This 8 that you're multiplying by, technically it's on top. And the -8 that you see already in the problem, the red, that's on the bottom. So it's not going to be -8 times -8, which is positive 64. No, it's -8 on top times -8 on the bottom, which cancel out. And that's what you want, because you want the y all by itself. So it's y equals, and then of course, what you do to one side, you do to the other side. And on the right side, both numbers are technically on top. So you're actually going to do 3 times -8, which is -24. One more example. So x over 7 equals -4. Same thing, right? Line through the equal sign. You have the left side, you have the right side. The x is on the left side. The 7 is also on the left side. So it's just, what's the operation between the x and the 7? This fraction bar means dividing again. So in order to get rid of it, you must multiply. So we're going to multiply by 7. The 7 on top times the 7 on the bottom cancels out. It does not equal 49. It cancels out. The x is all by itself, which is our objective. And then, of course, what you did on one side, you're going to do on the other side. And -4 times 7 is -28. And that is it for the first part of chapter 4. Call me over if you have any questions.